Hello everyone, my name is V Dinesh and my roll number is 536 and my topic is JavaCam trimming Java down to size. Java is both a programming language and a collection of libraries or packages. Many programmers prefer programming in Java over C or C++. Java's primary competitors. Not only does Java offer a large collection of packages for building complex applications quickly, but it is platform independent and strongly typed, allows for secure execution of untrusted code, untrusted code, and uses a garbage collector heap, a flexible API. Most of operating system support required by the Java VM in JDK 1.0.1 is listed in a public file system API.h, which is part of standard JDK 1.0.1 distribution. In a port to a traditional operating system, it would be necessary to write some interface glue to map the cells that the Java VM code was making into the actual calls supported by the OS. Because JN does not have a fixed API, we simply design the JN API to exactly match what was needed by the Java VM code. Support for Java VM code. The support required required by the Java VM code falls into six categories. Thread routines such as system thread create and system thread resume. Monitor routines, which include system monitor and system monitor exit. File routines such as read, write, open, close, and so on. Exception handling routines, socket routines, and various miscellaneous routines that are largely standard Unix routines such as malloc and free. JN does not support the dynamic loading and running of programs. Instead, JN is linked with the application as a single image, that is, we link JN with Java VM. The Java VM is run by calling the main routine of the Java interpreter. Memory requirements. Table 1. In table 1, as we can see that comparison of memory required by JN and to commercial embedded Java systems. In this, we can static size includes code, data, and BSS. Table 1 lists the memory requirements of Windows CE and VxWorks, two commercial Java embedded implementations on JN. The static size numbers do not include the class files. We were unable to obtain static sizes for the Windows C version because the class files and the native code are bound together in the several DLLs. JavaCam, a remote network sensor. Our goal was to build a sensor that would both be accessible via internet and demonstrate Java's built-in support for dynamically updating code running in the embedded system. JavaCam 5-hour network camera is an example of such a remote network sensor. It is controlled by Java and can be and can program it over the network without being shut down. Such a device without be useful, for example, in security systems or for traffic monitoring. Features for our example application, we use a Kinetics Quick Cam, a commercially available product costing around $250. It uses a charge coupled CCD to take digital pictures. The Quick Cam receives control parameters and delivers image data using a standard bidirectional PC parallel port. Using the JavaCam system, the user can specify these settings via the Java Camera Control applet inside a web browser or via a camera control servlet. Camera driver. The camera driver provides the basic interface to the camera. It allows higher level programs to send commands to the camera and provides a simple interface to receive images. The driver communicates with the camera over the parallel port and provides a basic API of three functions. That is void QC initialize, in QC send command, unsend character command, unsend character parameter. In QC take picture, character array, character mode, integer length. These functions are implemented in C and called by Java native methods. Excuse me. JavaCam provides two distinct ways to access the camera over the internet at the Java level: the applet method and the servlet method. There is an HTTP server running on the JavaCam system. When a web browser issues an appropriate GET command to the HTTP server, the server sends back a page containing a Java applet. This Java applet called QuickCam applet communicates back across the network and contacts another server running on the JavaCam system, the QuickCam server. The QuickCam applet sends parameters to the QuickCam server and then requests an image. The QuickCam server contains a QuickCam object that has native methods that call a JN camera driver routines. The native methods fill in the image buffer and hands the buffer back to a QuickCam. The server then the server then sends the data over the network to the QuickCam applet, which displays the image inside the user's browser. To control a QuickCam on a JavaCam system, a class must be implement the camera control interface. A camera control servlet, if authorized, instantiated, and a given a reference to a camera object, which provides access to QuickCam JN device driver. The instantiated servlet is also given a socket providing a connection back to the client that provided the servlet. Once instantiated and started, the camera control servlet can perform any desired processing of camera data before sending data back to the client. Like an applet, the servlet runs with an security manager class. The security manager checks all servlet operations to make sure that no unauthorized operations are performed. For example, in JavaCam, servlets are not permitted to access the file system or open arbitrary network connections. And the conclusion is JavaCam represents an embedded internet device in which executing Java programs can be altered on the fly. With the public release of the embedded Java API, commercial developers should be able to build systems with memory requirements comparable to JavaCam. The embedded Java API permits system to be built that include essentially arbitrary subsets of the core Java classes, such as Java AWT. It even permits subsetting of the methods within a supported class. However, although embedded Java has freed developers to subset the Java APIs, challenges remain for embedded Java system. That's it, and thank you everyone.